Right, good morning, my dear students. Welcome back to class 12 online class. And this is physics for class 12. And right now we are still in optics. Optics, it carries the maximum mark as compared to other units. That's why we will take some more time here. So if we look back at our early derivation, we have derived this formula: A plus D is equal to I plus E. This is the relation between angle of prism, angle of deviation, angle of incidence, and angle of emergence. And the second formula that we have derived, this is the prism formula, which gives mu is equal to sine of A plus dm by 2 whole divided by sine of A by 2. This also we have done. And today we are going to see the thin prism formula. The thin prism formula that is based on the prism, which is considered to be smaller in size. Okay, so in today's class we'll start from this thin prism formula here. Okay. Now, let us consider a very thin prism. This is slim, let us say slimmer and taller here. That's the prism. I call this the A, B, C. And as usual, we'll take the incident ray here, the refracted ray, emergent ray. Then when you produce this line, there's the incident ray, and when you produce the another line, emergent ray, here is the angle of deviation. You can call it D. And two more perpendicular lines to be drawn. These are known as normal. Another line again here, this is normal. So you'll be having two angle of refraction. This is R1, this is R2, like we did before. And this will be an angle of incidence, and this is angle of emergence here. And your prism is made of a material of refractive index mu, let us say. So first, let us see refraction. On the surface, the left surface, AB, here we apply Snell's law. Mu is equal to sine of, here, angle of incidence divided by sine of this angle of refraction, sine of R1. This is question number 1. And similarly, refraction on the other side, AC, we get the same thing here. U is equal to sine of, but this time I will be replaced by E, emergence, angle of emergence, divided by sine of, the other angle of refraction is R2 here. So let me call equation number 2. And as the prism is thin prism means all the angles like I, R1, E, all these angles are considered to be very small. So as the prism is thin, the angles, what are the angles? Like I, R1, E, even R2 are considered as small. These are considered as small. Therefore, when you write this equation, there is equation number 1 can be written as sine I can be replaced by I here by R1. So because when the angle becomes small, sine theta is equal to theta. Okay, so you can remove this sine here, and you can only write I and R1 only here. This will give you I is equal to mu R1. Okay, and the other one here from this 2, mu is equal to, you can remove sine, so you can write E by R2 again, or this will give you E is equal to mu R2. So now you have got 2 more equations. This is 3, this one is 4 here, equation 3 and 4. So these 2 equations, 3 and 4, I'll be using in here. This equation that we have derived before, a plus d is equal to I plus e. So I'll put here. So using in the equation, a plus d is equal to I plus e. If you use here, which is equal to I can be replaced by mu R1 plus E can be replaced by mu again, R2 again. So this will give you mu common to both of them. So you can write R1 plus R2. Okay, so you have A plus D is equal to mu R1 plus R2. But we have already seen that the sum of the 2 angle of refraction, R1 plus R2, this is equal to angle of prism here. Look back to our earlier derivation. We have already seen this formula. R1 plus R2 is equal to angle of prism. Therefore, when you try to put here A plus D is equal to mu, instead of this R1 plus R2, you can write as A here. Or you can transfer A on the other side. So you have D is equal to mu A minus A. So this will give you deviation is equal to A mu minus 1. And this formula is what we call as thin prism formula, or simply deviation produced by a thin prism. Okay, the note I had already sent to you, this is a video that explains. So I'll be taking up one more topic, that is cause of dispersion of light, but I'll be sending in a separate video. Continue with our class. This is the second part of the video. I'll be explaining about this cause of dispersion. We all know that when white light is passed through a prism, the white light gets splitted into different colors. This one you have already seen in class 10 and lower classes also. And the primary colors are vulgar, so among these, red has the maximum wavelength, R for red. It has maximum wavelength, and this is the violet. It has the minimum wavelength. It means when white light is passed through a prism, the light of different wavelength are deviated through different angles here. And we also know that angle made by the incident ray with the emergent ray, this is what we call as the angle of deviation. Okay, now the first one is we need to know the deviation produced by a thin prism. deviation produced by a thin prism is equal to D is equal to, you can write D or del A mu minus 1. Let's call equation number 1 here. And there is one formula. We call it the Cauchy's formula. And from Cauchy's formula, it says that mu is equal to A plus B by lambda square plus C by lambda power 4 plus this to carry on here, where A, B, C are constant and lambda is the wavelength. So in all summarized together, you can write that, you can say that refractive index varies inversely with the wavelength. So this is given by Cauchy's formula. Okay, so when you look at this light, let us select the two extreme color. One is violet, one is red. This is the incident ray again. And suppose that this is your red. So this is the angle of deviation for red here. And the second one, I choose violet here. This is the incident ray. And violet should be at the lower portion. This will be violet with this angle of deviation of dV for the violet here. Okay, so now compare the wavelength right now. We know that red has maximum wavelength and violet has the minimum wavelength. So lambda for red is greater than lambda for violet. So larger or longer wavelength means the refractive index is less. So using this formula, when the lambda is very large, the refractive index for red is going to be less than refractive index of violet here. Okay, and from the equation number 1, from this equation, D is equal to A mu minus 1. When the refractive index becomes less, angle of deviation also less, because these two are directly proportional. So what you can say is deviation for red, this is again less than deviation for violet, simply because this red color has less refractive index. Less refractive index means less deviation. This is the equation you have. So this means that red will be deviated the least, like this. Red is deviated the least here, and violet is deviated the most. It means that deviation for violet is more than deviation for red. I think you understand what I'm saying. So our conclusion is violet deviates the most and red deviates the least. So it means that there is deviation of different colors. It is nothing but your dispersion. So when you conclude like this, it has already explained the cause of dispersion of light here. So you can write, which explains the cause of dispersion of light. Okay, you just go through one more time. So I do hope that you are following my videos, and this is the second part of the video. And for scattering of light, and in the scattering of light, you will be explaining like the blue color of the sky. Why is sky blue in color? Okay, and the sun, when it is rising, it appears to be red in color. Like when the sun is rising, it appears to be red in color. and during sunset it is also red in color. Why is it so? It need to be explained separately. So I'll be sending you those phenomena in the note